Now, just a reminder, this is just one episode in 4 in our series on CryoEM. Stay tuned for the other shows or check them out. Check out the show notes here for links to them. Yusuke Yamada is an assistant professor there and an X-ray crystallographer. His colleague Toshio Moria is an associate professor and a CryoEM guy. And thankfully, I had Brian Shervin with me. He's our CryoEM guru on the HPC specialist team here in AWS, and he acted as my Sherpa through the whole experience. There's too much here, though, for one episode, so we're breaking this discussion up into 4 shows. In the 3rd episode, we'll discuss the impact all this had on the efficiency and utilization of the facilities across the country, and the way it changed the way individual scientists work, which is where the real impact is felt. And in the final episode, that's a deep dive into the arsenal of benchmark data they've amassed, which the CryoEM junkies watching this channel can use to make their own decisions about what's going to be the best CPU and GPU combinations for your workloads at the resolutions you're working at. Today, we're discussing the impact all of this had on the national grid of CryoEM facilities, and especially how it changed the workflow for individual scientists.
Yeah, this is, as you know, that the DCB, nice DCB interface. So it looks like your normal desktop computer, right? So for many people, it's easier to use Reliant as it is if you used to it. And also that often that the exporting has a big problem with Chimera because of the OpenGL. This is one of the really nice components which runs very robustly, because we tried different remote desktop environment software, right? And often the OpenGL had a big problem or security problem. So it's really nice. I love it.
And being able to do this in a web browser is really, really weird. It feels very strange doing a complete desktop visualization through a web browser interface. At least the first time you do it, it feels weird. And after that, it feels kind of, it's just fine. But it's a very strange experience the first time around.
Yeah, and one of my user actually said, "Oh, I can check that my analysis result when I'm commuting on the train."
Hey, that's fantastic.
Yeah,
supercomputing by Shinkansen.
Yeah, exactly. You can run. Yeah. So the problem is that I told this to my boss, and the boss said, "Nah, you have to be able to do through the cell phone." So we had to develop it. So maybe Brian can help us.
Yeah, but Boof and I will talk about that with the guys in Italy.
So the CryoSpark will support the cell phone interface.
Okay, we have to get to work on this, apparently. Let me go talk to Paolo. That's right. You guys, get to work. Get to work.
Yeah, exactly. That's why I love it. I love talking with you, Brian.
Thank you very much.
Problem solved, apparently. You're saying prior to this, you were literally doing the experiment, gathering the data for the customer, sticking it on a USB hard drive and putting it in FedExing it to them.
Yeah. But with our facility, we do differently.
Right.
So most of the facility, what I heard is basically they are using the hard disk solution still, and they don't have the download server. So we are sort of advanced, in my opinion, about this aspect. And if we can go into the AWS on top of it, then they don't even need to worry about downloading their own input.
Yeah, downloading
ship it once. Yeah.
Downloading is shipping it once into S3, and then everybody grabs a link.
Something like that, or S3 bucket and copy if you want, or they can just we can directly send to the S3 bucket or the raster of the head node.
I'll jump in because I've had this discussion with some customers a few weeks ago. That live processing is extremely important because it's important that you check that you had your sample preparation correct. One customer I talked to, they saw these beautiful structures coming off. They were so excited, and it wasn't until the very end of the run, like 24 hours later, that they realized it was a contaminant that they had grown and spent 24 hours of scope time and compute time for absolute crap. So being able to do this live processing, and you do a couple of hours and see if it's making sense. If it is, great, let it run. If not, kill it, and you don't waste your time and money on something that's incorrect. So
and if the latency in this whole scenario was the time it took to FedEx a hard drive to somebody, that's certainly not possible.
Or 2 days of downloading. Yeah. I mean, that's literally a week lost right there of a scientist's time.
Yeah. And often we need some feedback from the user to choose which hole or the grid scale they want to take. So that part that we use heavily online meeting software.
But that's pretty amazing. You can have a Zoom session and be sort of giving live feedback to a running CryoEM session and tweak it if needed, and that's pretty cool.
Yeah, that's very cool. Yeah, I'm very happy about the change over the world because of the. It's unfortunately bad reason, but there is some good outcome of our experience. So,
COVID has taught many of us new things about what it is possible to do remote and how life can be a lot easier. This show on YouTube is basically an outcome from that, because we needed to work out how to have these conversations more often without having to get together in person. So
yeah.
This is good. This is cool. All right, so let's keep going.
Okay. So this is what happened before. So-called the BIND project in Japan. So it's for the drug development. Basically, it's the creation of the drug development. So it's a national project in Japan, which gave us lots of a huge budget, right? So there's many hundreds of the lab or the research institute and university are involved. And then before the BIND project, we had only one CryoEM or a few. And we have some lesser, like 200 kilovolt or 100 kilovolt machine for we can use for the screening. The center of our director of our center basically organized all the Japanese researcher who have the CryoEM or basically the electron microscope machine, which they can take that use for the screening, get together and created the network, so-called CryoEM network in Japan, right? So this is connected so far by human. But I wanted to go further because as Brian said, the preparation, data, everything is separated, means we are doing the closed science. I wanted to make the open science. So what I come up with, if we are using cloud, then we can connect all the machine, CryoEM machine and operators and analysts together, like Internet of Things for the CryoEM network, right? This is basically what we want to do. And I think that this idea is, we come up with this idea because we are working for the shared facility, right? This is very helpful for the users. And I think it will help also the other facility and also users. So this is what we are aiming for, using cloud computer as a hub of the CryoEM of IoT. Then we can make the usage of the CryoEM much better. And on top of it, we can accumulate all our expense and knowledge and data on the cloud system. So yeah, I mean, this is very unique for the Japanese needs. So, but I'm not really sure whether the US need it or the Europe need this kind of system, but at least for Japan, it's really necessary for us.
The ability to share knowledge and share infrastructure like this, I mean, everybody needs that pooling of knowledge so that we can actually, concentrate the expertise where it matters. Everybody needs that. The question is how to get it. You guys have come up with a really cool solution to the problem. Really, really cool. This is something that everybody else should take as an example of what to do.
Great. Yeah. Well, I mean, that the AWS is the same concept, right?
Yeah, Aggregating the expertise, removing the undifferentiated heavy lifting. Yeah, you guys have done that for CryoEM.
We just connected the CryoEM, so we include the CryoEM into the cloud system, basically.
Now, just a reminder, this is just one episode in 4 in our series on CryoEM. Stay tuned for the other shows, or check them out. Check out the show notes here for links to them. If there's something you want to see us cover in a future episode of Tech Shorts, come and find us on Twitter. Our DMs are open. Arigatou gozaimasu.
こちらこそどうもありがとうございました。
Thank you.
Thanks.